This is the flat tire detector. You just saw some examples of it in action being used to classify tires in real time as either full or flat. Here's a close-up of the system so you can see how it's built. The device is made up of a 3D printed housing that contains all the electronics, including a camera, microcontroller, LED, and battery. And the housing connects to a stand that is used to position the device and aim the camera so that it is in view of vehicle tires as they drive in front of the device. And the way the device works is, as vehicles drive in front of it, the camera continuously collects images of its tires and uses machine learning to determine if they're either full or flat, and then changes the color of the RGB LED to notify users of the result. Here's another look at the components that make up the system. This is an OpenMV Cam H7 Plus, which is a microcontroller board that includes an onboard camera. And Python scripts can be loaded onto this board to programmatically control the camera to capture and save images, as well as control the board's GPIO pins for any connected components. Attached to the OpenMV Cam is an RGB LED, which has jumper wires attached to it right here. And these plug into the pins of the board so that the Python script can control the color of the LED. And then finally, we have a LiPo battery, which plugs into the JST socket of the microcontroller to provide power to the board. Once the board is powered on, it automatically begins to execute a Python script that's loaded onto it. The script configures the camera settings and then enters a processing loop that repeats the steps laid out here. First, the camera captures an image of whatever's in front of it. Next, the image is processed through a trained TensorFlow image classification model. The model classifies the image as representing a full tire, a flat tire, or no tire at all. Finally, the RGB LED color is changed to notify the user of the result of the classification. This process repeats continuously and runs at about 5 frames per second. The image classification model takes input images and calculates a prediction value of what class it believes the image represents. Here we can see an overlay of these prediction values for live images captured by the camera. We can see that as a car drives into frame, images have a high prediction value for no tire. As the car's tires enter frame, the prediction value for either full or flat becomes the greatest.